The HTTP connect method is one of the interesting methods in the HTTP protocol that we don't really use on the daily basis like GET or POST, right? But it is very, very critical in the proxying and tunneling. In this video, I want to discuss the HTTP tunneling with HTTP connect because there's a new technology that replaces that, I guess, and I want to discuss that in another video. But I want to just make a dedicated video to discuss the HTTP proxying, HTTP connect method, what it does, what is the pros and cons, why do we need it, as per usual. If you're interested in all this stuff, make sure to check out this video. Stay tuned. All right, guys, my name is Hussein, and I discuss backend engineering in this channel, and mostly protocol, communication protocol, such as HTTP and any method. And when it comes to proxying, like this one, HTTP connect. So in this video, we will discuss the HTTPS proxy. What are these? Because this is everywhere, whether you like it or not. Sometimes you explicitly set it. Sometimes you have it implicitly set without you knowing. And then we're going to discuss the HTTP connect method. What problems that is solved. Then we're going to discuss the pros and cons of HTTP method. And then we're going to discuss the new protocol that is being worked on by people from Cloudflare, such as Chris Wood and Lucas Perdue and others, which is called MASQUE, Multiplexed Application Substrate over QUIC Encryption. I know it's a long name, but we're going to just touch upon it and see what problems does it solve in the HTTP connect method. How about we jump into it? So guys, what is an HTTP proxy? If I, as a client, want to connect to a server, but that server is beyond my reach, I don't know, it's blocked for certain IP addresses or only allow access to certain IP addresses. So what you want to do in this case is you want to communicate to a proxy that is able to access that target server, and it's able to access it, and the proxy will make the connection on your behalf. So that's one advantage of using a proxy. Another advantage, as we see it in the service microservices architecture, where service mesh, right, where a client doesn't know how to talk to the target server. It uses a protocol that just doesn't understand, or it's just not willing to install the necessary networking library to talk to. Like it uses HTTP 2, but I don't know how to talk in HTTP 2 because I have a HTTP 1.1 library, right? Something like that, example, right? So a proxy in this case, if it has access to a server and it knows how to talk to it, you can use it to connect to it. So the client can connect to the proxy, and the proxy makes the request on behalf of the client to the server. So that's the nutshell. So I'm talking here on pure unencrypted traffic, HTTP, right? Proxy. So let's take an example. Hey, I want to go to example.com on port 80, unencrypted, but I want to make a request, but I can't for any particular reason. I don't understand the protocol, or I just don't, I can't reach the server. So the proxy, again, unencrypted, what you want to do is, as a client, you would set your IP address, obviously, let's say 1234, and you would set a configuration that says the proxy server, and specifically the HTTP proxy, and you would set it as the IP address of the proxy and the port that the proxy is running on. Once you do that, request that goes to the HTTP protocol will automatically be delivered to the proxy first. And you might say, how? Well, we use TCP most of the time for HTTP, right? And so the destination IP address will be, in this case, the proxy. And we're going to show an example of it. So we're going to send your GET request to the proxy, and you might say, Hussein, how does the proxy know that to connect to the server, to example.com? Well, we have conveniently put a header in the HTTP protocol called host header, and then the host header called example.com, and before HTTP 1.1, that header didn't exist, so we couldn't do proxying, at least in the HTTP, unencrypted HTTP. There was no way to do that officially, let's say. So with that, now the proxy looks at the content. Why? Because it's unencrypted, so it looks and understands from layer 7 that, hey, you want to connect to example.com. Let me do a DNS, let me get the IP address, and then let me establish a TCP connection on the backend, and then let me send that GET request just for the server, but on your behalf. So, and the server responds back with, I don't know, 200 success. The proxy will respond to just forward back the result to you. So how does this look in TCP? When we look in the TCP layer, the data that we send, this is the IP address 9999 if I'm going to send it from the client to the proxy, and 8080, right? And from the source IP address 1234, which is me, and then this is the port, source port 1234, and a random number. However, when you look at this side, the destination becomes now this server, which is 555580, and the source becomes this, right? This is very important for software engineering to understand that this is happening on the back end, right? That's what's happening. Something is getting swizzled. We're changing the IP addresses. All right. So that's what's happening on the unencrypted side. So, however, what if the client wants to establish a secure connection to the target server? Not all this baloney unencrypted stuff. I don't want anyone in the middle to see what I'm doing. It is now encrypted. I want everything to be encrypted, right? That's why I invented TLS. So in that case, we will implement an HTTPS proxy. That's without the connect method. We're talking about, just let's use an HTTPS proxy. But here's what HTTPS proxy does. The HTTPS proxy decrypts the content between you and the proxy. So you will establish a TCP connection between you and the proxy and decrypts the traffic, and then looks at the data and then reconstruct the request to talk on your behalf, right? Because how does it know? How does it know to send the request if it's encrypted? So it has to decrypt it. So the proxy sees everything in this case, regardless. In the HTTP case, definitely it's unencrypted, so it sees it. In the HTTPS proxy, it also sees it, right? Because it serves you its own certificate even. So you will have to trust the certificate of the proxy. In this case, if you want to communicate in an HTTPS proxy. That's why if you want to subscribe to an HTTPS proxy services, make sure what you're doing, right? All this stuff, that if you're setting a proxy in your client machine, then they are looking at your entire content, except when they are using the connect method, which we're going to explain in a minute. All right, so that's generally bad, right? We don't want the proxy to see my content. I'm establishing a secure connection with the target server, example.com or google.com. I don't want anybody in the middle to see, right? But however, this is usually good for debugging purposes. And I use this all the time. There is an app called Fiddler where I want my app to connect to a proxy, and I want to see all the REST API requests that my app makes. We use Fiddler for that, for Windows, and I think Charlie for Mac, or other MIT proxy for other services, other operating systems. So that's how basically you do it, right? So what we need is actually a way to establish end-to-end encryption, right? Yeah, the word end-to-end is overloaded, but in this case, from me, the client, to the target server, this is end-to-end, and that's what I'm talking about here. So if I send an information, a packet, or anything, I'm making a search term in Google, I don't want the proxies to see that stuff. So how do I achieve that? Definitely HTTPS is not the solution. HTTPS decrypts the stuff, so it looks it terminates the traffic. It's called also the TLS terminator. That's another fancy term for it. So meet HTTPS proxy. Let's see how it works. Here's how it works. The client will establish a TLS. First of all, a normal TCP connection between itself and the proxy, and then sends the slice TLS client hello, right? But the server responds back with the proxy responds back with the TLS server hello in this case. Just so you're establishing a secure connection, nevertheless, between you and the proxy. So that's fine. But the moment you want to send any information, now the proxy turns around and establishes a secure connection between itself and the server. So it's terminated. The connection is terminated between this and this, right? So that's what we're looking at right now. So now the TLS server will respond, the example.com server will respond with its TLS certificate in this case, right? This is example.com. That's not what we want. We want HTTP Connect. HTTP Connect method does the following. It creates a tunnel between the client and the target server. And I know tunnel is a very fancy word, is being thrown around, so we're going to demystify it in a minute. Client sends HTTP connect to the proxy containing the target server that it wants to connect to. So if a proxy understands how to implement HTTP connect, it creates a mere TCP connection to the target server. That's what it does. So the proxy creates a TCP connection, doesn't establish TLS. Right? Once successful, once that TCP connection, the ACK successful, the proxy returns success to the client and say, hey, I created the connection for you. Now what? The moment you do that, once that's success, any future incoming packets from the client will be streamed directly to the backend. And this is called layer 4 proxying. Immediately, just, hey, I'm sending you a packet. Don't look at them. Change the IP address so that the source becomes you and the destination becomes that thing. And that's it. That's what you're supposed to do. In this case, including the TLS handshake becomes end-to-end, right? And let's see an example. So my proxy is this, and I am going to establish a TCP connection between the client and the proxy. That's already done. And now the first thing I send is HTTP connect to example.com 443 to my proxy. So the proxy looks at this and says, okay, you want to establish a TCP connection to this port. It doesn't understand what this port is. It doesn't try to be smart and say, oh, this is actually HTTPS traffic. No, you can put literally any port there. And if the proxy allows it, you will connect to it. You can put port 21. You can put 25, any port, and it will just establish a TCP connection to the backend on your behalf. That's why HTTP connect can be dangerous. So now the server will turn around and establish a TCP connection. That's just a TCP connection. So that's now formed. And the server, the proxy will now just say, hey, 200, okay, I just created the TCP connection. Now what? Now, the next step is the client understands that, hey, I just created the connection. Now I need to establish a TLS connection between me and the server. So it sends a TLS client hello to the proxy. And here's the thing. That's the beauty of this. It just sends it to the proxy, and the IP address is destined to the proxy. The proxy takes it and then changes the IP address from itself to the target server, and then just merely streams it to the backend. That's called layer 4 proxying. Just add layer 4 at the TCP stack. Just swizzle the ports. That's all what you need to do, and then poof, show it to the backend. Now the example.com server will respond with a TLS server hello for example.com, and the proxy will take the packet, says, okay, you're coming from this port, you're coming to this destination. I remember there is a tunnel between you and me, and that is essentially connected to this. So anything that you send to this TCP connection, I need to forward it to this guy. And that's exactly what happens. So the TLS is exactly end to end. From beginning to end, the whole thing is encrypted. You might say, Hussein, can't the proxy just look at the TLS client alone and decrypt the stuff? No, it cannot. That we have debunked that, right, with Diffie-Hellman. Diffie-Hellman, even if you're in the middle, if you look at the stuff, you cannot possibly decrypt this stuff. It's impossible. It's very, 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 very hard, right? Because you will have half the story. The only people who knows the private parts are this and this, right? The only way the proxy can actually look at the content is if the proxy responds back with its own certificate, right? Or somehow it forged the server certificate, which is very, very hard to do. It has to come up with a certificate authority that is trusted that can generate own example.com certificate for the proxy. That's impossible, right? It has been done once when one certificate authority has been shady, right? And was found, and it was shut down immediately. Let's talk about HTTP connect chaining. So you can do chaining. Yeah, if you have multiple proxy in the middle, and let's say you have the client machine, and this is my proxy, 9999.80.80, and this is the proxy that I'm connected to, 999.80.80. But this proxy itself has a proxy, which is another completely different proxy, 777.80.80. So how will this look like? Again, if the proxy software implemented the HTTP connect correctly, this is what will happen. The connect will be forwarded to this server. The server will find, hey, there's a connect coming to me, but guess what? It wants to connect to example.com, but I cannot do that. I cannot just jump to this because I have proxy. I am responsible to re-chain that connect to my own proxy. So it just forwards the same exact method to its own proxy. And then the proxy receives that and it doesn't have a proxy. If it does, it will do the same thing. If it doesn't, it will just it will do its job by establishing the TCP connection on the backend, which is the tunnel. And now it will just write back on the same TCP connection all the way to the back. So this is like a whole big tunnel. And now any content that you send here will be just streamed back all the way to the backend. And then the content will be streamed back to the front end. That's what will happen. So now you don't have to do HTTP anymore. You can send any data, right? In this case, it's 443. You have to send HTTP. But if I am connected to port, I don't know, 21, this is SSH, right? I can send SSH commands. And if the server actually listening on port 21 and has SSH server, I can essentially establish it SSH. This is SSH tunneling, but using an HTTP tunneling protocol. So let's talk about pros and cons of HTTP Connect. So it allows you obviously to connect to secure servers that you couldn't be able to connect to, right? Securely, right? Without the proxy sniffing around and looking at my content. So, and also a lot of protocol uses HTTP Connect behind the scenes to connect to the destination server in case the proxies do not understand that protocol. Let me give you an example. WebSockets. If you were gonna do an HTTPS true HTTPS WebSocket TLS termination, the proxy need to understand WebSocket in order to turn around and establish WebSocket on its behalf to the destination server. All right? What if the proxy doesn't understand how to talk WebSockets? And a lot of proxies don't, right? WebRTC is exactly the same thing. What if I don't, as a proxy, cannot sit down and from layer 7 build this protocol, build this packet in the way it's supposed to look so it's WebSockety, right? How can I do that? I know some proxies do that, like HA Proxy, I believe it supports TLS termination WebSockets protocol and Nginx as well. But what if it doesn't? You do layer 4 proxy. That's exactly what HTTP Connect for. So, and I talked about layer 4 of layer 7 proxy, and check out the video right here, guys. So the proxy, this client will say, oh, I want to connect to a WebSocket connection here. And if you have a proxy, immediately the WebSocket API on your browser will say, I don't trust any of your proxies. I have no idea if your proxy understands WebSocket. So I'm going to tunnel through. So it actually creates a tunnel between you and the destination server. So that's a tunnel. So now it can send technically any content to the backend. And when you send any content to the backend, you can basically stream anything, literally anything. It doesn't have to be HTTP. We just streamed WebSockets. We can stream WebRTC, right? And that's the power. That's the power of this. Now this leaves room for HTTP for smuggling content, which I think I forgot his name. Someone found an HTTP 2 on clear test smuggling bug, where you can smuggle content and bypass all the security on the reverse proxy. So like say if you have a reverse proxy and has rules and admin rules, and by creating a tunnel, you just bypass all the rules, because guess what? The proxy is not going to look at your content anymore, so it's not going to enforce the rules at layer 7. So guess what? It cannot do anything. So you can just stream everything. So smuggling is another con. I'm going to reference the video here. I forgot what it's called. Proxy can't read encrypted traffic. Beautiful things. We love proxies who cannot look at my stuff. Sometimes I put proxies that intentionally look at my content. Service mesh is an example, right? Service mesh is an example of a proxy and a reverse proxy at the same time. So chained proxies connect. You can do chaining. Oh, that's a beautiful thing as well. Cons. What's bad about this? The bad thing about this is it only supports TCP, right? You haven't heard about UDP tunneling, right? I haven't heard, at least. there may be a way, but definitely HTTP Connect doesn't give you UDP tunneling. So guess what? QUIC is out of the window. You cannot use QUIC and HTTP Connect method because the browser, first of all, the proxy is not going to create a connection. There's no connection in UDP. What does that mean? So there's no tunnel in UDP. So that's very difficult to implement. So that's the first thing. UDP, no UDP, is only TCP. And obviously DNS can't do DNS as well because it's UDP. Unless it's DOH or DOT. Each connect opens a new TCP connection. This might be expensive. So if I issued multiple connect requests to the same request target, then each connect method is going to open a new TCP connection, which is expensive. If I'm connected to the host, same host, why don't you, as a proxy, multiplex this stuff to the same host? Well, the question is, we can't because it's TCP. We need a proper protocol that supports multiplexing. And you might say, Hussein, what's wrong with HTTP2? Right? Well, nothing wrong with HTTP2. You can, but that's a lot of work to make Connect supports multiplexing. I don't believe, correct me if anyone hearing that, I don't believe any HTTP, there is no HTTP2 Connect method, right? I read an article that I think Cisco implemented something like that, where it uses HTTP Connect. If it's HTTP2 on the backend, their special proxy can actually tunnel you to a single stream, which is so powerful. So you have, as long as you're going to the same host, obviously, right? So you're gonna multiplex multiple stuff into the. But as far as we know, that doesn't exist. This thing doesn't exist officially. So another bad example is HTTP Connect can be abused. So if you have a bad implementation in the proxy and allow any port, guess what? I'm gonna use you as a proxy. I'm gonna set my proxy to be yourself as a proxy, and then I'm gonna tunnel you. I'm gonna do an HTTP Connect to tunnel you to a very famous SMTP server running on port 25. And then I'm gonna just issue spam mail on your behalf. Guess what? Who's gonna blame? No, it's not gonna. They're not gonna blame me. They're gonna blame you as a proxy because it's your IP address written all over it. So it's all your blood, my friend. So that's why HTTP Connect method and the RFC actually says that. I don't take my example. This is an example from RFC. I just took it and I literally explained it. So that's why the RFC recommends to basically do not open all the ports. Don't allow HTTP Connect to any port. so only allow ports that make sense, right? That's the same exact thing, right? That we run into the video I made with HTTP smuggling. Just don't allow any port. The problem was we were upgrading the HTTP using HTTP upgrade, and we were upgrading to a protocol that is just shouldn't be upgraded to, like HTTP 2 cleartext, and that protocol explained essentially created a hole, and that hole allows us to bypass all the proxy rules. So meet multiplexed application substrate over QUIC encryption. So people MASQUE, it's called MASQUE. So a lot of people are working on this. I know very, very little about it, but I just wanted to mention this just in case. So I gotta make another video once I am educated enough to make that video, right? People still, it's a shiny new thing. It's just being proposed, right? So what is this MASQUE? MASQUE allows UDP tunneling through QUIC essentially and through encrypted. So you're encrypted by default. We're gonna tunnel you through a beautiful stream. So first, you get multiplexing for free if you're going to the same host, obviously, and you get also UDP for free, which is awesome. So because we can't proxy UDP traffic, the QUIC and DNS cannot be multiplexed and cannot be tunneled, right? So MASQUE will allow that, facilitate that, allow multiplexing, right? Each connect method opens a new TCP connection. I don't want that. I'm establishing a lot of tunnels to the same TCP host, to the same host. Just use one TCP connection and create multiple dedicated streams for me, channels as I like to call them, and then stream my stuff directly to that backend directly, all right? And finally, it's secure. So Bad connect implementation will allow tunneling to any port. This will hopefully is gonna allow certain ports. It's not gonna allow everything, obviously. And I'm still learning about that more. Obviously, if anybody from the MASQUE team hear this, I'm asking Lucas, Purdue, and others to answer a few questions. Like, will MASQUE, for example, support TCP? I have no idea, because QUIC is built on UDP. I know there is QUIC has a backdoor to flip back to TCP in case of UDP is not supported, but in that case maybe it will support TCP. But I have no idea. So that's a small question that I have, and I'm sure as I research this technology more, I'm gonna have more questions. All right, guys, thank you so much for checking out this video. If you enjoy software engineering and back engineering, that's what I discuss in this channel. I discuss all sorts of back engineering. That's my specialty. I like communication protocols such as HTTP, MASQUE, all this stuff. I discuss this deep in depth, like what I did here on this video. So HTTP Connect, you go to Mozilla and they will give you a paragraph, but I make 30 minutes video on them because you cannot possibly finish a thought in 5 minutes, right? So you need deep dives, and that's what I discuss here. My channels might not be for you, but I do deep dive. I sometimes make short videos, but mostly I enjoy free form deep dive. So if you like this content, make sure to subscribe, share it with your friend. I'm gonna see you on the next one. You guys stay awesome. Goodbye.